Ladies and gentlemen, it's my great pleasure to introduce tonight's speaker, Robbin Jones. Robbin has been a member of the Astronomy Club of Tulsa for 10 years. His astronomy interest began in elementary school, and his father actually worked for NASA as a contractor in the 1960s on the lunar module project and on Apollo missions 8 through 17. That must have been pretty exciting. His father's workplace was at Redstone Arsenal, U.S. Army Missile Command in Huntsville, Alabama. On camping trips, his family would lay out under the stars and watch for shooting stars, i.e. meteorites. When he was a teenager, he saw the Milky Way on a Colorado backpacking trip for the first time and was mesmerized by its beauty, I think as we all are. His astronomy interests lay dormant for several years while he finished college and raised a family. I think, Robbin, this sounds familiar for a lot of us. In 2004, he and his wife, Rosalind, purchased an inexpensive refractor at an after-Christmas clearance sale on at a department store. One cold winter evening, as he was using the refractor, he pointed it at a bright blue star. As he looked more closely, he could just make out the rings of Saturn. So that was a good star to pick, I think, for that particular event. At the moment, his interest in astronomy was rekindled. A year later, he purchased the Celestron Eta C, the quote, one-armed bandit scope that a lot of people use within the club here, and spent many evenings in his backyard observing and learning what he could about the night sky. A nearby neighbor invited him to attend the Okie-Tex Star Party in 2010, and he attended each year since. In 2014, he began his plunge into electronically assisted astronomy, EAA, by purchasing his first video camera in an attempt to see more from his Bortle 9 backyard. So there is hope for us here in the Houston Light Dome, I should say. Since 2018, Robbin has gotten much more involved in EAA and currently has 4 video cameras and 2 remote control scopes and mounts. He does not consider himself to be an astrophotographer, but someone who wants to see more than the traditional eyepiece allows and maybe take a quick image. He enjoys the challenges of making various technologies work together to see faint objects from his suburban backyard in Broken Arrow, Oklahoma. Robbin, we're really excited to learn more about EAA. And as a club, we may have to straddle that line between visual and astrophotography and create an EAA special interest group as well. Yeah. So it's my pleasure to hand it over to you now, Robbin. Thank you.
Okay, thank you. I appreciate that introduction. Can you hear me okay?
We can, yes.
All right,
I'll stop my share here for you.
Yep.
And while Robbin's getting his presentation up, if you have any questions, we have a chat function within Zoom. Please feel free to ask those questions there. When we get to the end of the presentation, I'll collect all of the questions that you have, and we'll ask those in the order that they're received. So go ahead, Robbin.
Okay, good. Do you see my slides up?
We do.
Okay, great. Well, I really appreciate the opportunity to share what I do know with the group tonight. I was looking before we actually started to see if Mark Faraz was on the meeting tonight. He's a friend of mine from the Houston Club, and he actually introduced me to Don Sells, who then asked me to present, and then Don hooked me up with Joe. And so that's how that all came about. I've known Mark for about 5 years and have met a few other folks from the Houston Club when they come up to the Okie-Tex Star Party in the fall. So for those of you that aren't familiar with that, that's out at Black Mesa in Western Oklahoma. It's a beautiful dark site, a lot of fun, highly recommended if you can make it. So with that, let's jump in. So I want to thank just a few folks, my wife, who's also a member of the club here in Tulsa, one of our board members, John Land, who actually encouraged me to prepare this presentation, Mark Faraz, and Sven Schmidt, 2 friends of mine that I have gotten to know at the Okie-Tex Star Party, and they have seen this presentation in its early form and gave me a lot of good ideas. So I'm going to run through various things tonight, and I'm going to just give a basic definition of what electronically assisted astronomy is. I want to kind of talk about why I started, what are the benefits, what can you do with it, what are the basic prerequisites that you need to get involved, what are the challenges, what affects the performance, talk about the equipment that I'm using currently, and then give you some sample images. And then at the end, I have some resources on a page, and I provided that to Joe. I think he can send that to the group. It's a list of different websites and links, probably far more information that I'm able to share tonight. And then we'll have a few minutes for Q&A. So what is EAA? It's basically astronomy that's being assisted by analog or digital cameras that can provide images in real or near real time. And by that, I mean a few seconds to a few minutes. Some really bright objects you can see almost instantaneously. Things that are fainter, it may take 30 to 45 seconds before you see the image. To see a nice clean image may take 5 or 10 minutes. It just depends on what you're looking at, what your camera settings are, and what your the focal ratio of your scope. One major distinction: a true video camera can produce an image independent of a computer or any post-processing. So EAA has changed so much in the last few years. The cameras that are available now really bridge the gap between EAA and astrophotography. And I'll show some sample images that some guys that I know they put the Malin cams to use doing astrophotography and turn out some really nice astrophotography. I think it would stand up to just about anybody's work. But a true video camera doesn't need a computer to produce an image. You just need a monitor of some kind. And the range of the cameras in terms of that are used for EAA, they range from simple low resolution security cameras. Basically, they're repurposed or retreaded security cameras, all the way up to really high resolution 26 megapixel cameras. That's the highest video camera I know that's available now is 26 megapixels. It's a phenomenal piece of equipment. I've been drooling over it for several months thinking of buying one, but I think I better use the 4 that I've got now for a while before I make that plunge. It's in EAA, it's kind of like telescope fever. What's the right number of telescopes? It's n+1, where n is the number of scopes you already own. So there's always some other gadget that you want to buy. Some cameras, you have to have a PC to run them. Others, they just have buttons on the back, and they don't require any computer control at all. But the computer does give you a lot of flexibility. And lastly, another form of EAA is a night vision ocular. My friend Mark in the Houston club, I saw him last fall. He had his night vision ocular, put it in his 25-inch Dob, and we were looking at the Horsehead and the North American Nebula and several other nebulas. And it was just amazing how fast that image popped into view. So that's just another aspect of EAA. So why did I start? If you look at this map, it shows Tulsa, and I'm going to annotate here for just a second. So this is the heart of the light dome in the city, and I live about 5 miles south of it, right there. And our club's dark site is about a 45-minute drive. It's probably 30, 35 miles away. And I do enjoy going out there, but I don't enjoy driving home at 3 o'clock in the morning when I'm bleary-eyed and really tired. My wife doesn't like it when I'm out all night like that. So I was really just trying to find a way to be able to see more from my light polluted skies. And I had read an article somewhere that that you can see a lot with video cameras from even a light polluted sky. And so I made the plunge several years ago, and I bought one of the earlier Malin cams, the Extreme. It's a CCD camera, and kind of used it off and on. Really didn't use it as much as I would have liked to. And then a few years ago, I really got into it much more. But as far as the sky conditions at my house, it's a Bortle 9 sky. Someone might argue it's Bortle 8, but I can see Albireo. I can see Mu Andromeda. You know, on a good night, I can see a magnitude 4 star, but most of the time it's a 3 magnitude sky for me. You know, I do admire the images that astrophotographers take, but I really don't have hours or days to take one image. I have a friend in our club here, and he will spend 15, 20 hours taking data to create one image, and he turns out absolutely fantastic images, but I just don't have that kind of time because at the time I started into EAA, I was fortunate if I could observe 2 or 3 nights a month. So there's no way I could take that limited time and get up the steep learning curve to learn how to do astrophotography and turn out anything that I would be happy with. I wanted to be able to see things I couldn't otherwise. I remember many times slowing my scope to where M33 was supposed to be, and I would look and I would look and I would look, and I couldn't see anything. And the only place I've ever seen it with my eyes has been at a dark site like Okie-Tex. And there are many other images that fell into that category. I've only seen the helix visually, the veil, many other objects of that type, faint nebulas. I've only seen them at a dark site, and I really wanted to be able to see them from my backyard. And so astrophotography was just kind of out of the question from a time standpoint. I wanted something kind of in between. Most of the images that I take, you know, for planets, it's milliseconds, so it's really real time. For DSOs, you know, a single image as far as a frame to load on the camera could be as long as 45 seconds, but lately I've really amped up the focal reduction that I'm using on my scopes, and most of my exposures are 20 seconds or less right now. And when you stack the images, they tend to clean them up. They take out some of the noise and make them much more crisp and clear. And usually I'll stack an image for 5 to 10 minutes, depending upon which object it is. I like technology. I've always enjoyed trying to pull different pieces of technology together. I got into ham radio when I was 12 years old, and have played with that off and on over the years. So I just like technology, and I enjoy science also. As Joe mentioned, my dad worked for NASA, and it was always cool to be able to, you know, get to see what he was doing at work. He would take us to the Space Museum sometimes on the weekends there at the missile base, and we could see, you know, moon rocks and things like that. It just always had a strong interest in science. So what are the benefits? Obviously, you can see a lot more, and colors are very evident. I'm always amazed by some people that can look through an eyepiece and can describe all these different colors of a deep sky object, and I look at it and all I see is shades of gray and maybe a little bit of kind of a purple blue, but I don't see much else. Obviously, something like Herschel's Garnet Star or Betelgeuse or some of the other, you know, definitely orange or reddish stars, I can see that. But as far as seeing colors in DSOs, I can't see it. But with EAA, you can see colors because it shows them in their native element. The thing that I really like about EAA, especially in the last few years, is when you're set up right, you can enjoy it out of the elements. You can either do it inside, you can do it inside a tent, or you can do it inside your home. And it's very easy to show others what you're looking at. You don't have to worry about someone kicking the tripod, knocking the scope out of alignment, or uh, putting their thumbprint on your eyepiece. I'll never forget years ago, I was showing one of my best friends' family some of the typical showpieces, you know, and I had my little 72 millimeter refractor, and you know, they all came up and they were looking at the double cluster and a few other things. And I asked each one of them before they went to the scope, I said, you know, here's where you focus. Please don't touch the eyepiece. And then his mom walks up and sticks her finger right on my brand new 24 millimeter panoptic eyepiece and puts a smudge on it. I could have fainted, but I smiled. But you don't deal with that. You don't deal with that with EAA. If you're using one of the simpler cameras with a video grabber, you can snap a simple, it's basically a screen grab of what you're seeing on your screen. And with software, special software that runs some of these cameras, you can get some pretty decent looking images. So the benefits, you know, there's a lot more that you can see, obviously, but there are many paths that you can take. Observing is obviously at the top. You can do screenshots, you can take longer stacked exposures, and with the right equipment, you can pursue high quality astrophotography. For the astrophotographers on the Zoom meeting tonight, I do not claim to be an astrophotographer. I aspire to be that one day, but nothing that I'm going to show you tonight, I think, reaches that level. So please be kind and merciful to me because I'm not an astrophotographer. You can take videos, actual MPG files or AVI files of you know, the planets, and then run them through programs like I think it's Auto Stackert, that will choose the best frames and allow you to do really nice planetary imaging. You can video transits, and I'll show some examples of that later. And then another option is to do some spectroscopy. And I have not done that, but I do know some people that have. That requires some extra equipment. And I have a link that I gave to Joe that if you're interested in that, you can buy some special masks that go over the camera, and also some special software. It lets you do emission and absorption lines, calculations, and calculate redshift, which is pretty cool. And maybe one day when I retire, I'd like to pursue that kind of stuff. You know, the basic prerequisites, you need a telescope, obviously. You need a tracking mount. People do use alt-az mounts, but German equatorial is better, and I would say preferred. And if you want to capture any kind of an image, you need a computer. Now, I do know some people that just have a little simple video monitor screen and they take a snap of what they see with their iPhone, and that's okay. But you don't have to start out real sophisticated, and it's really best to start out simple. So let's talk about some basics. There are two different types of video cameras. There's a CCD and a CMOS-based camera. And several years ago, pretty much the only thing that was out there was CCDs. But in the last couple of years, they have become more of a CMOS-based camera. And I think that's probably true for astrophotography cameras as well. And the reason for that, as I understand it, there was an article in Sky and Telescope, I think about 3 months ago, that talked about this. Most of the CMOS chips that are produced for cell phones, and CCD chips are really not being produced nearly as much anymore. Each chip has its own advantages and disadvantages, and we'll talk a little bit about that. You know, a decent camera can really effectively increase your aperture. Obviously, it doesn't physically do that, but because the camera is so much more sensitive than your eyes, you can just see more with the same size scope than you can through a visual eyepiece. The faster the scope or the more focal reduction you use, the better it's going to be. You know, F5, F6 is great. I have used F10 for planetary, but the two scopes that I'm using now, one is at F6.7 and the other one is at F6. As I said earlier, German equatorial is the preferred mount for doing EAA. You need a frame grabber or some type of software if you want to capture the image other than just snapping it with your cell phone. The sensor dimensions determine the field of view. So the smaller the chip on the camera, the smaller the sensor, the smaller the field of view. It's kind of like an eyepiece. The more glass on an eyepiece, typically, the more glass area, I should say, on the eyepiece, the larger the field of view. And it's very similar with the sensor on a camera. And the pixel size affects the sensitivity of the camera. A larger pixel is more sensitive. Think of it as a small light bucket. So we talked about just a moment ago, there's two types of cameras, CCD and CMOS. CCD stands for charged coupled device, and CMOS is complementary metal oxide semiconductor. And they both essentially do the same thing, but they do it in different ways. As I understand it, a CCD reads off each row of pixels one at a time and then runs those through an amplifier. With a CMOS chip, every pixel is read independently, and I believe each one has a little bit of an amplifier on it. So they're made differently, they behave differently. I'm certainly no expert, but from what I have read and what I have seen with my own cameras, I would say that the CCD cameras tend to have less noise, and the CMOS cameras are a little bit noisier, but for the same amount of money, you can get a lot better resolution with a CMOS camera versus a CCD camera for the same dollars that you're willing to spend. I want to talk for just a minute about a concept of what's called binning. So binning basically allows the camera to electronically combine adjacent pixels, and it behaves as one pixel. So what that means is if you're doing a 2x2 binning, it effectively increases the size of the pixel by a factor of 4. And if you're using 3x3 binning, it effectively increases the size of the pixel, the simulated pixel, by a factor of 9. So it makes it more sensitive. And this is very useful because it makes the camera more flexible. So you can run a camera, for example, I've got one of my cameras, the highest resolution camera I have is 10 megapixels. And frequently I run it at a 2x2 binning. So it basically gives me 2 megapixels, a little bit more than that, 2 megapixels of resolution, but the sensitivity is far, far better in 2x2 binning, and it's really handy on dim objects. Now, if you're dealing with something really bright like M31 or the Great Orion Nebula, M45. No, excuse me, M42. M45, I believe, is Pleiades. You can really crank up the resolution because they're so bright, you'll get a nice image and you don't need near as much sensitivity. So as a moment ago, I mentioned that I see pixels as light buckets. And I know this is kind of a pretty simple graphic, but think of each of these buckets in this top picture as a pixel. And I think of light, you know, as little photon raindrops. And if I'm trying to get a dim image to show up, you know, on my camera, and I've got a small pixel, I'm going to have to wait longer for those photons to fill that bucket up, so to speak, in the pixel. So by binning, I basically increase the size of my bucket so that it does collect light photons more often than it does in a, say, a single 1x1 configuration. I'm going to talk about costs for just a moment. You know, a low resolution camera, like a 0.5 megapixel camera, which is really just a retreaded security camera, you can buy those from anywhere from $125 to $200 new. Probably one of the more commonly known low resolution cameras that's out there is a Revolution imager. And I see those pop up on cloudy nights for sale about 2 times, 3 times a month. I have a camera that is a similar resolution to that, and I paid, I think, $120 for it used on cloudy nights. A high-end camera can be $2,000 or more, and that would be like a 26 megapixel camera. But then there's lots of choices in between. You can buy a brand new video camera that's really good for between $700 and $1,000, and you can buy them used for anywhere between $500 and $800. So there's a lot of options out there. 3 of my cameras I bought used, and only 1 of them did I purchase new. And I'm going to make a statement here that might upset some of the old timers, but in my experience, if you've got a lot of TeleView high quality stuff in your eyepiece case, I bet you've spent on 2 Nagler eyepieces, you probably spent more than what it would cost you to buy a camera. And with that camera, you can see more than you'll ever see in that eyepiece. Now, there's pros and cons to visual and EAA, and we'll talk about that also. But I still have TeleView eyepieces. I still have some Explore Scientific eyepieces. I've got some nice eyepieces. I don't have any Naglers because they're so pricey, but I've got some eyepieces I paid $500 or $600 for, and 2 of those would buy you a camera. So just something to think about. So what are the challenges? It really depends on how complicated you go. I'm going to annotate here for just a minute. Over here on the left is kind of the simplest configuration. I've got the camera right here going into a diagonal. And by the way, that's not the preferred method. The preferred method is to go straight in with no diagonal. But that's where I was when I was starting. And then you just have a tracking mount and a scope. And this is a 5-inch refractor. I know that's a big refractor, but I've also used this with my 72mm refractor, and it works fine. Obviously, I can see more with a larger refractor, but a small refractor works just fine. And when you go to this middle picture, this is one of my 2 remote controlled scopes. And I have added a Star Sense auto alignment camera. You can't see it, but I have a polar alignment camera on the front. I have a finder camera and a guide camera, and then there's my CCD on the end. So this arrangement has 4 different cameras on it, and 3 of them are for the sake of making what comes out of this better. So, and then I've got this other on the far right. That's my 8-inch Schmidt. That's my one-arm bandit that I bought off of Craigslist several years ago, but I put it on a better mount. And then it has a Star Sense, and I've got a 10 megapixel camera on it, and then a low resolution 0.5 megapixel camera that I use for a finder camera. So. Okay, what are some of the challenges? I think probably one of the biggest challenge that I ran into before I got my first camera, I would see these pictures that people would take, and I would be all excited, and somehow I unrealistically expected to see something of that quality the first time I used it, and that didn't happen. It was a little disappointing, to be honest with you. And it took a while for me to learn how to use the camera. I probably could have done a better job reading and studying about what other people had done and what they were doing with these cameras. And I kind of learned the hard way, and I don't think that's really as hard as I made it out to be early on. But the point is, the learning curve can be steep, and there's new terminology and technology that you have to learn. When you get into more complex equipment where you're trying to run it remotely, it can be challenging. You know, all the software and all the software, all the cables, the computer issues, it's probably similar to astrophotography. You know, just trying to make all that stuff work can be anywhere from a mild challenge to a real hassle. And I really encourage you to just start out simple. Don't try to do anything overly ambitious when you first start. You know, some evenings are magical, others can be very frustrating. I think the most important thing is to learn from every experience. And one of the things that I have been doing for the last few years, and I'll just kind of show you, I've got this, well, you can't see it with that video, but I've got a logbook, and every time I have a session, I write down what I looked at, I write down the things that worked, I write down the things that didn't work, and if there's something that I can do to tweak it and make it better, I write it down and I act on it, and I just try to refine it over time. And it's taken me a few years to get to the point to where I am now. And I still have a long way to go, but I'm much happier where I am today than I was even 2 or 3 years ago. You can get some really nice images with time and post-processing. Some people have done a really great job at that. You really have to learn the camera. There's just nothing that substitutes for time with the camera. You know, I've heard people say when it comes to visual, nothing substitutes for time at the eyepiece. It's the same with the camera. And I would really encourage you to start with simple, bright objects first. You know, look at the double cluster. Look at M13 if it's up. Look at, you know, this time of year, Orion. Look at Orion. Look at the crab. Look at, you know, in the summertime, look at the ring nebula or the dumbbell. Those are all pretty bright, easy to see objects, and they show up really well in the camera. One thing that I would point out, I do sometimes miss the quiet serenity of being outside with no computer to fool with, no electronics, and just being at the eyepiece and just being out in the quiet and just looking at the sky. And, you know, when it's 50, 60 degrees and the wind isn't blowing and there's no mosquitoes, I love it. But when there's mosquitoes and it's really cold and the wind's blowing really hard, it's no fun. A few nights ago, when I put my scope up, I think it was a week ago, I put my scope up, there was a thick layer of frost on my scope, and there's no way I would have been outside observing like that. I think when I put my scope up, it was 24 degrees. But technology, it can be a distraction, but so can the elements. And one of the things that EAA allows you to do is get out of the elements. So, Joe, here's time for our little poll.
Certainly. Can you guys see the poll on the screen there? The question is, which one of these is Robbin's photo and which one of these is Jim Misty's? I see some of the votes are coming in right now, so we'll give it another 10 seconds or so. Go ahead and get your answer in.
No fair. There's too many astrophotographers in the group. No fair.
All right, we'll go ahead and wrap up the polls here, or this particular question now.
Yeah.
So
okay,
we'll
all
go ahead
right.
and share those results. Do you guys see that by chance?
Yeah.
So,
So
70% said they believe the one on the right is yours.
And they're correct. They're correct. But what I would like to point out is that the image on the left is absolutely stunning and beautiful. I mean, Jim Misty does excellent work. But what I'd like to point out, a lot of the detail that you see in the image on the left shows up in the image on the right. And the image on the right, I took from my backyard here in Broken Arrow. Now, here's the details. So Jim Misty's image is about 2 hours, and he took that with a 32-inch Ritchie Cretin at a dark side at 4,500 feet elevation. And I took mine with an 8-inch Schmidt, 15 minutes exposure total, and 5 minutes of post-processing. And I can see the image, not that high quality, but I can see the nebula in about 15 seconds. But I don't see all that detail. It takes time to bring the detail out. So let's go to the next one.
All right. Once again, we've got the poll up. You feel free to answer when you get a chance. We'll give you about 20 seconds. Again, the question is, with this picture of the helix, or these two pictures of the Helix Nebula, which one of those is Robbin's and which one is Jim Misty's, done using astrophotography?
Too many astrophotographers in the group. Not fair.
We'll close the poll in about 5 seconds or so.
Okay. All right.
All right, we'll go ahead and share these results. The overwhelming number here said the image on the left is yours, Jim. Or excuse me, is not Jim's, is yours, Robbin. So
yeah, and they are correct. They are correct. But I'd point out that again, the image on the left, this was taken with my neighbor's backyard lights on. And I think it was a quarter moon, and from the backyard. So again, Jim Misty, an hour, mine was 20 minutes, and it was hard because the helix is low in any way. But still, there's no way I could see that from my eyepiece. There's no way. I've only seen this visually at Okie-Tex, and that was using a filter, and I had to have an old timer at my shoulder telling me what to look for. So, okay, one more.
Last one here. So again, picture of M16, the Eagle Nebula. One of these is Robbins, and the other one is Jim Misty's using several tens of thousands of dollars worth of equipment and several thousands of feet of altitude as well. So we'll keep the polls open for another 5 seconds or so.
Oh man. Okay. Now see, they've all caught on to my color schemes. No fair.
Exactly. So I'll go
No
ahead and
fair.
share these results. We're starting to catch on to you, Robin. We're seeing your
Okay.
images. Yeah. So 98% there. Thought the one on the left was yours and the one on the right is Jim's.
And that is correct. But what I would say is I am in no way trying to say that the image that I captured is as good as Jim Misty's. It is not. But what I would say is if you look at the detail, and I'm going to use a different color so it'll stand out. Let's see here. If you look at the detail in here, for example, it still shows up. See those little stars there? They still show up. Look at this faint cloud in here, and this little guy here. I mean, a lot of the detail that's over in Jim's image, and again, he does fantastic work, shows up over in my image. And there's no way I can see that at the eyepiece from my backyard. There's just no way. So anyway, that was a 15-minute exposure. Jim Misty's was 2 hours. I spent 5 minutes post-processing. I'm pretty happy with that. Can I do better? Absolutely, I can do better if I spend the time. But again, from my backyard, I'm happy with it. So, and then I just want to show a little quick graphic. So on the left is my scope that I took that image with, and on the right is Jim's scope. And if you can't get the idea of the difference in size of the scope, maybe this will give you an idea. This my little scope here versus his, I mean, that's a barrel. That's huge. And I mean, I wish I had something like that, but I mean, my gosh, I bet his mount costs more than all the scopes I own put together. So anyway, I'll move on. So what other performance factors? Obviously your equipment, the resolution of the camera, the pixel size, the size of the scope, the focal ratio that you're running the scope at. Faster is better. And I know some people that use these Star Arizona hyperstars on their Schmitz, and they get really nice big Y fields doing that. The tracking, you know, if you're going for just a few second images, it doesn't matter so much. But if you're going for, you know, 30 seconds, 20, 30 seconds, you really need to have good tracking. Sky conditions obviously make a difference. This time of year it's really hard because our neighborhood celebrates the holidays so much so that about every other house is lit up with Christmas lights, and so the sky glows even worse. So, you know, the sky conditions make a difference, but I can still see a lot more than I can with my eyes. And the temperature, if depending on the camera that you're using, in the summertime, longer exposures will show more thermal noise. And noise is just signal that's generated within the camera itself, and it's not from any light that's reaching the pixels. So here are some of the other things, and I'm going to try to speed this up a little bit. The camera settings, obviously how long an exposure, gain, you can amplify the signal. Histogram just basically allows you to clip off different parts of the signal to either make it darker or brighter. binning we talked about earlier. Gamma is a setting that basically improves the visual perception of the image. The higher the gamma, typically the darker the background of the image. In other words, like what should be a dark sky is darker with a higher gamma. And then stacking is basically where you're just adding images on top of each other, and you're improving the signal to noise ratio so that more of what you're trying to see shows up, and the signal of the image of the object overwhelms the noise. And then there's dark and flat field correction, and that can be done on the fly with some of the cameras that I use. And it's really pretty slick. Some of the software that's available today is just phenomenal. And then hot pixel correction. Some pixels show signal even when there's no signal. So they're basically busted, if you will. And with software, you can correct that. So the performance is really a balancing act of your equipment, polar alignment and tracking, the sky conditions, the amount of sky glow. I use a light pollution filter here in town. It helps quite a bit, in my opinion. You can shorten the exposure time with using more camera gain, which basically is just amplifying the signal. But when you amplify the signal, you also amplify noise and sky glow. So there's kind of a balancing act between those. Excuse me. Need to get a good focus. The simple way to focus is to just adjust the focus until the stars are as pinpoint as possible. A better way is to use a Batinoff mask, which I'm showing here on the left, and you just put that over the scope, and it creates these diffraction spikes, and you just adjust the focus so that that long central spike bisects the other two spikes. And it's pretty slick. I wish I was smart enough to figure out how to invent something like that. It's pretty handy. So I'm going to talk about my cameras and what I've got. Just going to run through this quickly. And for those of you that are maybe taking notes, Joe told me that they are recording this, and this will be available later on. You can play it back. So don't worry about trying to capture a bunch of details, because this is going to be available after the Zoom meeting. So on the left is my my simplest camera. It's called a Malicam Micro. It's a CCD. It's a 0.5 megapixel. It is really a retreaded or repurposed security camera. You can go up to 17 seconds with it and stack 5 frames. You don't have to have a computer to make it run. I paid $100 for it. It works fine. And I'm going to show you some examples of images from that. And if you look on that bottom left corner of this slide, let me annotate real quick. You can barely see it, but there's some buttons on the back of the camera. And when you push those buttons, you access an on-screen display of a menu that lets you change exposure and gain and things like that. And then on the right is my Malicam Extreme. And those are $1,400 new, but I've seen several sell for between $500 and $800 within the last year on cloudy nights. And again, it's got it has buttons on the back of the camera that you can access a menu to change exposure and different camera settings. You've got these different ports that your video comes out here. This is for controlling the camera remotely with a computer. Here's just a look at the chip. You can see it's pretty small, but it's a very sensitive camera. It's very sensitive, and I really like it. but because it is so sensitive, it's got really big pixels, the resolution is not that great. So when I first started using it, I was really amazed by what I could see and I liked what I saw. But then when I bought a 10 megapixel camera, I don't use this one near as much. So in the last 2 years, cameras have just become so much more sophisticated and higher resolution and can do so much more for the same amount of money that I would have paid for this camera even 4 or 5 years ago. It's just like with any other technology, it's just really rapidly accelerating. Here are the other two cameras I have. On the left is the Malicam Universe. It's the largest CCD that I have and that Malicam sells. It's a 6 megapixel camera. It's got big pixels. It's a big sensor. I can see with focal reduction through my refractor at f6, I can see almost 2-degree field of view with that. It's really nice wide field view. And both of these cameras are cooled, and that's to reduce noise, and they both will cool the sensor down to 80 degrees below ambient temperature. So I typically run my my DS10C Tech, which basically is the 10 megapixel color thermal electrically cooled CMOS camera. I usually run it at 32 degrees. And this time of year, I don't have to run the cooler on the Universe. There's not that much noise. If I ran it this time of year, the chip would be running at about 50 below, you know, and that would actually, so let me think, yeah. That'd be running about 40 or 50 degrees below zero. And you get a lot of dew formation when you do that. So anyway, this camera on the right is probably my favorite camera. I paid $950 for that used. And I would have to say, I'm not a paid Malicam spokesman, but the support and the service I have gotten from Malicam has been absolutely outstanding. I have nothing but good things to say about them. I've had a couple of small issues and they took care of both of those. And when I asked them to send me the repair bill, they said no charge both times. Just amazing, amazing. The other thing about this camera on the right, it's got fairly small pixels, but it allows you to bend as well. And it allows you to do dark and flat frame correction on the fly. You can adjust the cooler to anywhere that you want it to be. And what I really like about it, it's got a built-in dew heater on the sensor so that even if I cool it really low, I never have a problem with the camera fogging up. So I really like that. Okay, moving on. So this is one of my setups. It's an 8-inch Schmidt. The way it's set up is about f6.6. I've got a focal reducer in it. Gets me a little less than a degree, about 0.8 of a degree. And for the novices on the call, basically that would be about 1.5 full moons width. So full moon is about 0.5 degree if I remember correctly. I've got that small camera that I pointed out early on. That's my 0.5 megapixel camera. I use it basically as a finder camera, much like you would use a finder scope. And I can also use that as a guide scope if I want to. This is the 10 megapixel camera here. Then I've got the star sense align, and that just saves me from having to align the scope. It does it automatically. It saves me maybe 10 or 15 minutes. I did also put a microtouch motorized focuser on it so I can adjust focus from inside my house. Uh, let's see. So let me annotate this real quick. How am I doing for time, Joe?
You're doing fine, Robin.
Okay, all right. I don't want to go too long. So this is the scope that I showed you a minute ago, but if you notice, there's these control wires, and they are running the mount, the cameras, and then those run through a conduit that I had put through the wall in my house, and then those go inside, and I'll show you in a minute what that looks like. But then underneath the scope, I've got a little box. Basically, it's a storage bin I bought at Walmart for $5. Now I've got all my electronics in there. I've got a powered hub and some other things that are collecting and condensing all the wires and putting it into one hub. In this case, I'm using two to control the scope. And that's what you see over here on this left-hand picture. Like to clear this annotation and then just show you again something. I built this homemade rolling tripod holder. I made it with scrap lumber. It's made out of 2x4s and plywood, and it has locking casters on it. So all I have to do is roll this thing out, and if you can barely see it, I've got masking tape on my patio. I roll it out to a predetermined spot. I lock the casters, and usually I'm within maybe half a degree of where I need to be with Polaris, and within a couple of minutes, I'm polar aligned and I'm ready to go. And someone may be asking, well, why are you telling us all this? What does it matter? Well, before I set up this rolling tripod, which basically lets me keep all my equipment ready to go anytime, when I had to take everything out, put it all together, set it up, and then take it all apart, I was spending a total of at least an hour and a half between tear up and set down. And if I'm only getting to do this 2 or 3 times a month, that's really eating into my observing time. So with this current setup, I can be ready to go in 20 minutes at the most, and I can be done in 10 minutes. So that gives me a whole nother hour to observe. So I really like that. And that, for me, was a real game changer, because before, when I had to set up and tear down, I just didn't do it as often. And on a work night, I would hardly ever do it. But now with this, if it's a nice night and it's clear and the moon isn't too bad, I can roll this thing out and I can observe for a couple hours and still put everything up and take my shower and be in bed by 10 o'clock. I couldn't do that before. I would have spent an hour and a half just setting up and tearing down. So this control wire right here on the far right that I showed you, it comes into my den, and then it goes to my laptop, and then my laptop is connected to my big screen TV. And this time of year, it's far more pleasant to observe sitting on my couch and looking at this on my big screen TV. So, and my wife knows where I'm at, and she's not worried about me ending up in a ditch somewhere because I fell asleep at the wheel driving home from a dark site. So, it's really been a game changer for me. Okay, I'm going to show you some sample images, and we're going to be done here probably in 10 minutes or less, and then probably some Q&A. But all these images that I'm about to show you, I took from my backyard with a few exceptions, and I will note what exceptions those are. So this is the moon, obviously. This was done with my Extreme. It's a 0.5 megapixel camera. I think my focus could have been better on this. This is the moon from the universe at 6 megapixels. This is the moon at 10 megapixels, and I stack these in registacks. A lot more detail. And while I think this is pretty good, I've got some friends that use the same camera, and they turn out images so good you'd think you're walking on the moon. I haven't gotten that skilled yet, but I'm working on it. This is M31, and this is with that little Malicam micro, and this is a single 17-second exposure. And I know it's not that impressive, but compared to what I can see from my eyepiece from my home, about all I see from my eyepiece is this. But with this little camera, you see these dark lanes. I couldn't see that from my eyepiece in my backyard. This is from the extreme. And here you're definitely seeing more some of the the lanes in M31. Bear with me here. And then this is from my backyard with a 10 megapixel camera, and I think this one took me 10 minutes. And there's no way I can see that with my eyes. I'd have to go to a dark site, and I have to, walk around with a Sinbad patch on my eye for 45 minutes, and then I might see some of this detail. I know other people are just far better visual observers than I am, but I'm just ecstatic that I can see this from my backyard. And then you see the little companion galaxies. You see M32 and M110 there. Pretty exciting stuff. And this is Orion, and this is through the little Malicam micro. And this is one 17-second exposure. And you can see, the challenge with these little cameras, you don't have as much control over what all you can see. So the trapezium is blown out, but you do see some detail out here. And granted, you can see some of that detail through the eyepiece. I mean, I have before. And then you've got the Running Man over here. So I know that's not super exciting, but it's decent. Let me go to this next one here. And then this is from the extreme, and you can make out the trapezium. I think I had this slightly overexposed, but here's a trapezium, and you're starting to see more detail out here and in there. This is from the universe, and admittedly, when I took this, I was probably not very skilled with that camera at that time, so I don't think this is a fair representation of what that camera is capable of. That camera will turn out much better images than this, so please don't condemn the camera on my lack of skill. And this next one is from my favorite camera, the 10 megapixel camera. And I was using what's called a live high dynamic range method. Basically, what I did is I ran a bunch of very short exposures, like 500 milliseconds, so I could capture the trapezium. And then I layered in and built in longer exposures up to like 15 or 20 seconds to capture the detail further out. And all this builds on the screen while you're sitting there. So a lot of detail in this picture, and I like this. I have seen far, far better, I know, but I'm pretty thrilled that I can see this from my backyard. And I was really happy that I was able to get the trapezium without blowing it out. It took me, I hate to admit it, probably half a dozen times before I was able to get that to work. So here are some other images from my backyard. And just to kind of put it in perspective, I live 1 mile east of a super Walmart, a Lowe's, a Reacher's Grocery, which is like Howard E. Butt's grocery store there in Houston, a Costco on Memorial Drive, which is a major 4-lane highway. Think FM 1960. Now you got the picture. There's the Ring Nebula. Now you can see the ring visually, but I don't see that detail through my eyepiece. There's the dumbbell. Again, you can see the dumbbell, but before I started doing this, I never saw this part of the dumbbell. All I saw was that. I saw the bow tie. That's all I saw. So this is the Trifid. I don't know if I'm pronouncing that correctly. I'm almost scared with all there's probably thousands of years of visual experience in this group. So I hope I don't get crucified for mispronouncing it. I call it the Trifid. Some people call it the Trifid. I don't know. But you can see this is a very nice object for the novices that are on the call. It's an emission and a reflection nebula. The emission nebula is the kind of the orangish red on the left, and the reflection is the bluish on the right. It's a very beautiful object. And here's Mr. Eagle. And I can actually see the eagle in about 15 seconds. Now, I don't see quite all the detail that you see in this image, but I can make out the eagle in 15 seconds. And it's low in the sky too. Here's the lagoon. And by the way, this image of M16 and of M8, I cropped those to approximately the same field of view as Jim Misty's so people could do the comparison. But you can see the field of view is much larger with the focal reduction that I was using. Here's M13, beautiful glob. And some people are really talented at using these cameras to tease out more detail, to resolve more of the core, to be able to see more detail in the core. I have not mastered that technique yet, but I'm hoping to. I'm hoping to. This is the crescent. Again, all these are from my backyard. And most of these are anywhere from, I can't see what it says at the top because I'm in full screen, but most of these are anywhere from 10 to 15 minutes of total exposure. This is the veil. I think this is the eastern veil, yeah. And I was never able to see the veil from my backyard before I started using these cameras. I've only seen it at Okie-Tex, and that was with an O3 filter and an old timer at my shoulder telling me to wiggle the scope and look. And here's a running man. That's in Orion. I think that's right. Yeah, it's in, or is it just outside Orion? I forget which. This is the cat's paw. That's pretty low. And there's no way I can see that with an eyepiece. There's Mr. Horsehead. I've only seen the horsehead at Okie-Tex twice. through an eyepiece, and that was through somebody's huge daub. But I actually can see the horse head. It's not real good, but I can see the horse head on a full moon night. It's not great, but it's detectable. With this camera, I can see it. I think that's the Needle Galaxy, one of the spring objects. Okay, is Debbie Moran on the call still? I hope so.
Yes, I've been waiting for this.
Okay, all right. So we had a dry run the other day, and I was on the presentation last night, and Debbie talked about the Rosette Nebula and said that it was the official nebula of Oklahoma, and I had to participate in a Houston Zoom meeting to find that out. I did not know that. So she asked me to find out what's the story behind that. So I did a little research, and here's what I found. So Oklahoma's state flower is the Oklahoma rose. The state rock of Oklahoma is the Rose Rock, which is a barite sandstone deposit that forms, and it looks like a kind of an orange petaled rose. And the history of how this became the state nebula, some folks in the Oklahoma City Astronomy Club, they're very active in putting on the Okie-Tex Star Party out at Black Mesa. They talked to their state representative and asked them to make it the state nebula, because our state flower is the rose and our state rock is the Rose Rock. So now we have the rose trio. We have the flower, we have the rock, and now we have the nebula. So there you go.
Thanks. I feel better now.
Okay. All right. We're going to finish up pretty quick here. So here's M51. And again, there's no way I could see that level of detail through my eyepiece. This was Comet Neowise, and I wish that I was more skilled with the camera. I would have liked to have done a better job capturing that, and got the long comet tail and all that. But I was pretty excited that I could see it. I did see it with binoculars. It was very bright. But I captured this from my backyard also. And this is kind of cool. I'd like to take just probably an extra couple of minutes on this one. I forget when this was. I think this was back in August. So if a friend of mine who's part of the same camera users group, he said that there was going to be a transit of Jupiter's moons, and the red spot was going to transit. And so I set up my 10 megapixel camera and I did videos of it at different times over the course of about an hour and a half. And if you look at the upper left-hand corner, just on the edge, you'll see one of the moons just on the limb of Jupiter. And this is another one of the moons that has already started to transit. I forget which one it was. It was Io or Ganymede, one of the two. And so here you can see it, the shadows moved, and you can just see the shadows starting to form. The red spots moved. Now you can clearly see the shadow. That shadow's moved. And then when you get down to the far right-hand corner, you see everything has moved. And I did this with my video camera. Now, it took me some time because I think I captured maybe 5 or 10 minutes of video, and then I had to stack them to get that detail to pop out. But it's still kind of cool and exciting to be able to do that. So Let's see. Okay. Just a couple of other images. These are not mine, but I made the comment earlier that you can do astrophotography quality imaging with these cameras. And I want to show a couple of examples of that. These are guys that I know that use mailing cams for astrophotography. And if you're going to do this, you need longer exposures, you need really good tracking, everything you need for astrophotography you need. But my point is the higher end cameras, the higher resolution cameras, the ones that are, you know, several megapixels are capable of turning out really good stuff. And this image is from Tom File from Austin, Texas. And this is 14 hours of the Gamma Cygni Nebula. And he did this with 3 or 4 different narrowband filters. I mean, that's a phenomenally beautiful image, in my opinion. I ascribe to hopefully be able to do something like that someday, but I don't have the time right now. But that came from a video camera. Pretty incredible stuff. Then this is Thor's helmet in Canis Major, and Mickey Huffman from Texas put this out, and it's using the same camera that I'm using, the 10 megapixel camera. He did this through a Dob. Some people use Dobs, not many. Most people use refractors or Schmitz or Ritchie Cretans, but he did this with a Dob, and I think it's beautiful. I mean, I see the helmet big as day. It almost looks like a skull there in the middle to me, but. And then another one from Mickey. This is the Monkey Head Nebula. And he did that with that same 10 megapixel camera. And I think this is beautiful. So here are some resources, and Joe can make these available to you if you need them. It's just some links to different sites or articles that I've read that I have found helpful. There was an article back in June of Sky and Telescope that was pretty informative. These are just some nice resources if you're interested. And then here's just a list of video camera manufacturers. Celestron makes some. Malicam, obviously I'm a big fan of Malicam. There's Omega, Orion makes some, QHY, the Revolution Imager, Starlight, ZWO, and I think there's some others as well. But I'm only familiar with Malicam. I'm sure these other cameras would do you a good job. There's some software out there called SharpCap, which a lot of people use. And with that, I'll open it up for questions. So.
Great presentation, Robin. Thank you. And those are beautiful images. It's amazing to see what you can do, like you said, with the video camera. And we've got a lot of really accomplished and published astrophotographers in this group. And I mean, what you're doing is absolutely amazing. And in a fraction of the time that it takes them to create some of the wonderful images they make. We do have quite a few questions, and we'll try to get through them pretty quickly if you don't mind. I know Justin McCollum had a couple of questions, one about a monocular night vision eyepiece and another one about filters.
Okay.
Justin, are you there? Do you want to come off mute and ask?
Yeah, I'm just wondering what type of, you use any type of night vision eyepieces or night vision equipment for EAA?
I do not. The only one that I have seen is one that Mark Faraz, a member of your club, has. And that's the only one I've ever seen or been able to use. And that was over a couple of nights. So he would be a better resource for you than I. If you don't know Mark, I'm sure Joe can hook you up with him.
Yeah, I know Mark. And like, what type of, do you use any type of filters during your session?
Yes, I I use here in town, I use an Orion Sky Glow imaging filter.
Okay.
There are several out there. I think Optilon makes one. Astronomic makes one. There are 3 or 4 different filter manufacturers out there. I like the Orion Sky Glow imaging filter. I tried a generic Celestron ultra high contrast or light pollution, an LPC light pollution contrast filter, and I didn't like it. The Orion Sky Glow imaging filter is really good, at least in my opinion. But I can't tell you that I have tested a lot of filters. There are some guys in the users group that I'm a part of that have done extensive testing and comparison, and some of them are better at different types of objects than others, but I like what I get from.
Okay, thank you.
Yes, sir.
Excellent. I think Ed Franey had a couple of questions as well. One about whether all the images were taken from your backyard, but he also had a question about broadcasting observing sessions. So Ed, do you want to come off mute and ask? Ed, are you there?
Yeah, I'm trying.
Okay. There you are.
I'm familiar with, well, just vaguely familiar with some of the guys are doing or broadcasting their observing sessions from, like you, from their backyard using, I believe, YouTube and some other platforms where, you can just, people can just get connected via the web and share the experience with you. Have you done any of that kind of stuff?
I have not. That's on my list of things to do, but the group that I'm a part of, you can go out there. It's liveskies.org, and usually, if the weather's decent somewhere, somebody's broadcasting, and you can see how these cameras work and what people are doing with them, and it's fun. I think they ran into an issue recently. There was like 130 people trying to get on one of these sessions, and they exceeded their user limit. But it's pretty common for there to be 20 or 30 people on it's similar to Zoom, but I have seen at most 2 or 3 different broadcasting sessions going on at the same time. Usually there's one person out there if the weather's decent somewhere. But to answer your question, no, I have not done that. That is on my list of things to do. I'm trying to learn how to walk and chew bubble gum at the same time before I do that. So I'm not sure.
Excellent. Andres Salaveria asked a question. Andres, do you want to come off mute and ask it yourself?
Yeah, I can. Can you hear me okay?
We can.
Yes, sir.
Great, thank you. Yeah, I actually sympathize with what you said, because I suffer from the same to setting up the equipment and taking it down and all of that. I live in Houston, borderline sky. So my questions are, I actually have two. One is, what software did you use to capture the images on your PC? That was one question.
All right. So most of the images that I showed you were captured using, it's called Malincam Sky. It's software that comes with the CMOS camera. The software is free. It comes with the camera. It's in the public domain, but it only works with the Malincam camera. And they regularly update it. I think since I've had the CMOS camera for a little less than a year, and they've had 4 updates within a year. And they'll add different features to improve the camera or fix little issues with it. That's one software. That's what I used for the 10 megapixel camera. Then for the extreme, there is a freeware called Cam Control.
Mhm.
I've used that, and then there's another one called Milo Slick, which is a third-party product, and I've used it with the Extreme, and it's excellent. But it's pretty inexpensive. It's $50. I mean, how can you beat that? It's wonderful software. And then for the small video camera, the Cam Micro, just a screen grabber will work, like an Easy Cap screen grabber or Dazzle or something like that will work. Just anything that would convert a composite video into USB and put it on your screen, and then you can do a screen capture with it. So I've used all three of those. I've used four different softwares, but I've mentioned three of them. But the one I use the most now is Cam Sky. I think it's extremely robust and outstanding. It lets you do dark frame correction on the fly and flat field correction on the fly, which is phenomenal. I mean, it's just wonderful, wonderful.
Okay, thank you. The other question very quickly, how long are your cables going from the telescope to the computer? I'm curious about the signal.
Sure. So I can flip back to that. So to answer your question while I'm doing that, the USB 3 extension cable is 50 feet long, and the USB 2 extension cable is 60 feet long. And they are what's called active extension cables. And at the scope in that little box underneath, I'm using what's called a powered USB hub. And that's to make sure that I get sufficient power and voltage to the camera so that it works properly. A typical USB port will put out 5 to 5.1 volts, but if you're going over a long distance, by the time you get to the camera, it's going to be 4.5 volts, 4 volts, and the camera's just not going to work. Mm-hmm. So those are powered cables and powered hubs. And I have used both batteries at the scope, and just a few months ago, I converted over to, I've got a power supply running at the scope now with about 8 different power ports that powers all the different items.
Okay, thank you. Yeah, power, that's another thing that I found it's one of the challenges. Thank you, appreciate. I mean, this was awesome. Thank you very much.
Yes, sir.
Excellent. Our good friend Dan Roy had asked a question about focusing, and I think that was before you got to the Batonov mask. Dan, did you still have the question?
No, I think he covered it, even though I don't know how to use this thing.
Join the club. Maybe we could learn one day at the dark site. Well, is that the primary source of focus for you, Robbin, is a Batonov mask?
It is now. I mean, you know, it's you can get pretty darn close without the Batonov mask, but if you're going to do any really fine image capturing, the mask is really helpful. And I found, I don't remember which distributor it was. I bought the ones that I have off of Amazon for like, I don't know, 15 bucks a piece or something. And usually at star parties, there's a vendor that's selling these things. You know, someone that's got a laser CNC that can cut plastic will generate these things and sell them by the dozens at star parties. Like, I'm sure TSP will have someone that sells them. I find it very useful. If you don't have a Batonov mask and you're using like a Schmidt, you know, with the Schmidt, you can go out of focus and you see the classic big donut. Mm-hmm. Well, you just keep adjusting focus till it gets as small as possible. And then if it starts going back the other way, you know you've gone too far. And so you just adjust the focus until it's as small as possible. So that's not ultra scientific, but the Batonov mask makes it scientific. But there's actually, I found out recently, there's a new Batnoff mask, and I don't remember the name. It's a tri-Batnoff mask, which supposedly aids in the collimation of a Schmidt-Cassegrain. That if you get all the diffraction spikes just right, you've got collimation nailed. But what I have found to help me with collimation on my Schmidt is using MetaGuide. Actually, I put the imaging camera direct into MetaGuide and use MetaGuide to adjust the collimation screws. Adjust the collimation screws and watch MetaGuide, and it will tell you when you've got your collimation nailed down. And MetaGuide is a freeware that's out there in the public domain. So.
Great. Thank you very much. I know we've got a few more questions, but I was curious as to whether you had time for maybe 2 more, Robin?
Yeah, sure.
Okay. Renee Gadeli, our own membership chairperson, had a question about exposures and seeing what's in the eyepiece. Renee, are you there?
Yeah, I am.
Hey, Renee.
Robin, absolutely amazing images. Thank you so much. I'm a visual observer though, and I have been looking for a way to approximate what the eye sees, and then what one could see through binoculars and then through smaller medium telescopes. And I was wondering if you thought that this might be approached depending on how you know, how long exposure, that kind of thing. I know that's.
So if I understand the question, can you adjust the exposure length of the camera to simulate what someone could see through with their eyes versus binoculars versus a telescope? Is that the question?
That is.
I think you could. I mean, there's images that, I typically run my camera when I'm just finding things or going from object to object. I usually run it at about 1 second exposure. And, frequently I'll slew to something and you'll say, okay, well, I think I'm there. Like you go to M51 or M33 and you slew to it, you're on 1 second. Well, you see a few stars and you go, okay, well, I think I'm there. And then you crank it up to 10 or 15 seconds and bam, there it is. So you can play with the exposures anywhere in between to simulate what you think someone may or may not be able to see with a different aperture binocular or scope. So I would think the answer is yes, but I think there's probably programs out there that would do a better job of that maybe than playing with a camera and doing that. But if you've got the camera and you've got the time, I don't know why you wouldn't be able to do that. So
Thank you, Robin. Yeah, I know there are other things out there. I haven't been happy with them, but since I do know what certain objects look like through binoculars or various aperture of telescopes, I think this would be great. Thank you.
yes, ma'am.
All right. Jim King had a question about wedges. Jim, do you want to come off mute and ask? If Jim is still there. I think he may have.
You got me?
Yeah, there you are.
Oh, yeah. Thanks. First, I want to say thanks for a great presentation. You do seem to be enamored, of course, with Jim mounts. Wondering if you have any experience with the alt-as using a wedge. I hear they're pretty good. Wanted your opinion.
Well, I don't have any direct experience with them. I do have some friends in our club that have used a wedge with an alt-as and they seem happy with it. But I don't have any personal experience with it. I just know that some people use alt-as scopes without any wedge, and for short exposures of 5 or 10 seconds. If you're running a really fast scope, maybe f5 or something, you can probably get away with that. But if you're going to go with a longer exposure and you try to stack those, you'll start seeing field rotation in your images. So I don't know why a wedge wouldn't work for you. It should. And because if I understand it correctly, when you set them up for a wedge, you're just moving pretty much in right ascension and only moving deck when you're going to a different object, I think. So I don't know why it wouldn't work.
Okay.
All right, thanks. Don Borg Anderson had a question about dew buildup. Don, are you there?
Yeah, I am. Thanks for your presentation. It was wonderful. And this is probably a good notch or two down your skill set. But when you're shooting the, the flats and the dark flats, the lights and the bias frames, I've always been taught so you can reuse them to keep them at the same temperature, which up in Michigan was about negative 10 Fahrenheit. And that was a couple miles off of Lake Huron. So there was an interesting dew point there. Well, we're what, 20 miles as the crow flies from the Gulf, and Houston has a kind of interesting dew point too. Like I said, what you're doing is probably way beyond what I'm discussing here. But when you're running your cameras, what temperature do you tend to try to keep them cool to here in Houston?
No, that's a great question. The CMOS camera that I use most of the time now, let's see, that's this guy on the right.
Okay.
I run it at 32 degrees.
Okay.
And I find that I don't have much noise when I run it at 32. You can run it down to below 0 if you want, but my understanding from the manufacturer is that you will shorten the life of the sensor if you do that. He's got a pretty novel cooling system with his cameras. I think years ago it was conventionally thought that you can't cool a CMOS camera, but he's come up with some way to do it, a proprietary design. But I run them at 32, and I do my darks and flats at 32 degrees. So I do my darks at the same camera settings as I'm shooting my image. And when I do my flats, for the astrophotographers, please cover your ears because you're just going to cringe when I tell you what I do. I get the cleanest white t-shirt I can find in my drawer, and I tie it around the scope. And about 10 minutes after the sun goes down, before it's completely dark, I just point it up at the sky and I set the exposure so that my histogram shows a nice signal build about half to a third of the way from the left-hand side of the histogram. And I do a white balance and I do a stack of 5 and I call it good. And I'm not using any fancy light panel or anything like that. I'm just pointing it at the sky about 10 minutes after the sun goes down when there's this nice even illumination. And I do that at whatever bin size I'm going to be using. And usually I capture, 3 or 4, 2 at one bin size and 2 at another, and I'm good to go. And you only have to do that if you move your camera. So as long as you don't move your camera and touch your optics or clean your optics, you're good. So
I found the very best way to do flats at the George was to point the East Dome at the side of the research dome with the moon coming up.
There you go. Get some of that
anything
reflection.
else we tried with like sheets and light sources, and nothing worked as well as that.
yeah.
There you go. Do you have time for maybe, oh, thanks, Don. Sorry
here.
about that. Yeah.
I'm here. The only thing that's waiting on me is a beer after this is done.
Well, that's all the more reason to hurry up and not keep you on longer than we need to. But do you have time for maybe two more questions? We had two
I'm
more in there.
here. I'm
That
here
way
for
we
the
could get through all the
duration.
questions. Perfect. Chris Morissette had a question about storage. Chris, are you there?
Yes, I am. Robin, great presentation. A question for you on your rig. I like how you put the rollers and all on that. Where do you store your system at? And if it's not inside, if it's out in a garage or someplace, how do you store it to keep the dew and the dust and everything else off of it?
No, that's a great question. I do store it in my garage. Let me see if I've got a picture that would show that. It's kind of hard to see. Let's see here. So back here around the corner of that brick wall is my garage. There's the edge of my garage. So I roll the scope back here and back around on the sidewalk and back into my garage. And if I turn the tripod sideways a certain way, I can just get it in my garage door. And I built that's probably an overstatement. I've got a small piece of wood. It's a wood wedge on either side of the door sill so that the casters will roll up smoothly over the door sill. The only challenge that I've had doing that, I have to be careful. If you jostle the scope a lot, it will mess up how level the scope is, or it can, over time you need to check your collimation because, I'm rolling this over creases and seams in the patio, et cetera, et cetera. I do store it inside. I have had a challenge with dew, even though I'm running a dew heater outside. When a dew heater outside running when it's 30 degrees, and then I roll it into my garage where it's 50 degrees, dew will start forming on the scope. And that aggravates me to no end because cleaning that Schmidt is a real pain, and I really don't like touching those optics. But I had such a bad problem with dew this past spring that I've had to clean that scope twice this year because of dew. So I'm giving you a long-winded answer. So what I do now, what my standard practice now is, when I'm finished observing, I roll it into the garage, I plug the scope in, and I continue to run the dew heaters while I put everything else up. I take a shower, I do whatever, and then I come back in the garage, and 30 minutes later, I turn the dew heaters off. And sometimes I even have to take a hair dryer and get the dew off before I close everything up. And a week ago, when I brought my refractor in, there was a thick layer of frost on it, and I had to leave the scope uncovered all night for all the frost and the dew to evaporate off of it. But it can be a problem bringing in your equipment out of a cold night, even with a dew heater, into even a 20-degree warmer environment and have dew form on your optics. And it's just so frustrating. You don't like to touch the optics or clean them any more than you have to. But yeah, dew has been a challenge for me. So long-winded answer, sorry.
It's okay. It's always been a challenge for us here in Houston as well. So thank you. And then the last question, Wesley Clavey. I hope I pronounced your last name correctly. Wesley, do you want to come off mute and ask about the fast start configuration?
Sure, thanks. And Clavey is right. Since you have said several times that faster is better, if you have ever used your Schmidt in the fast start configuration rather than putting the camera at the back where the eyepiece or the diagonal goes.
So you were cutting out there, but I think your question was, I'm getting an echo.
A little bit of feedback from Wesley.
Okay, I think the question was, have I ever tried the hyperstar configuration as opposed to using a focal reducer at the back of the scope?
Or
And the
fast
answer
star.
is, yeah, fast star or anything like that. Basically, what that does, for those of you that are not familiar, with a Schmidt, you've got a corrector plate up here, and actually the light comes in, hits the mirror, comes back, hits a secondary, and then comes back down into the eyepiece. Well, what happens with the fast star is you replace the secondary, and there's a special optics package that goes here that takes this scope, which is normally like f10, and makes it anywhere like f3 to f4. I have not done that. I do know several people in the users group that I'm a part of that have, and they're very happy with it, and they like it. I also know guys in the same users group that have purchased a Rowe Ackerman Schmidt astrograph, which is f2, and they get these huge, really wide field. I mean, they can get the entire veil, east, west, everything between nebula in one shot, and they're very happy with that. But to answer your question, no, I have not. All I have ever done is use just the focal reducers. I'm using a 0.5 focal reducer, but I can tell you after months of playing with it, and I've got, I don't know, I've probably spent $100 on different Astro toys to try to get it dialed in. I can get it to f5, but I get really bad vignetting in the corners of the images. I found that f6.6 gives me the best, flattest overall. It's the best combination of reduction and nice flat image. On my refractor, I'm using an Explorer Scientific 0.7 field flattener reducer combination, and it's phenomenal. It's really good. But answer your question, no.
Wonderful. Well, Robbin, thank you so much for taking the time today and sharing all of the wonderful images that you've taken using this technique. Like I said, for those of us who are not astrophotographers,
I'm not an astrophotographer.
I know. I was saying, this is really intriguing, right? This is a way of combining some sort of imaging system to enhance what we're doing visually. So I really appreciate what you were able to share with us tonight. And I, for one, and I'm sure others as well, are motivated to give this a shot now. So thank you very much, Robbin.
Well, you're welcome.
And by the way,
Thank
next
you.
time you're in Houston, let us know. I'd love to have you join us out at our dark site. So
oh, that'd be great.
absolutely.
That'd be great.
Absolutely.
I've got 2 grandsons in Houston, so that might happen. So
excellent. Just let us know when you're here.
okay.
Thank you. All right. Well, that's all we had for tonight's presentation. It was, again, a wonderful presentation by Robbin. I'm motivated to go out and try this myself. But we do have our February meetings coming up next month. So our novice meeting is going to be on Thursday, February 4th at 7 p.m. And our general meeting is going to be the following day on Friday, February the 5th at 7 p.m. So visit us at our website, astronomyhouston.org, if you have questions. For those members who weren't able to join us or only caught part of tonight's presentation, this will be recorded and put up on our website there for your viewing. And for those of you who did join us and want to catch maybe some things that you may have missed during the presentation, it'll be there within a day or so. If you're on social media, there are social media links there on Facebook, Twitter, and Instagram. And again, if you have any questions that you may want to ask of us here in the club, you can always send us an email at info@astronomyhouston.org, and we'll answer those for you. So again, thank you very much, Robbin. Hit us up when you're in Houston again, please.
I will.
And we'll see you all soon. Take care, everyone. Have a good night.
Thank you. Good night.